Hello, good morning. We are here to take a look today at lesson 10.4, and it's titled Misleading Graphs and Statistics. We're going to learn how to recognize how a graph or a chart or any set of data might be misleading, and we're going to recognize misleading statistics. We're on lesson 10.4. And I am just trying to find the page really fast. Our vocabulary for today, random samples. So we're going to be looking at statistics, taking samples, and learning how to assess all of the above. Graphs can be used to influence what people believe. The way data is displayed can influence how the data is interpreted. If we look at this graph, for example, the trained eye might notice right away that there's a break in the graph. What we want to do is take a look at the scale. 76 goes up by 2, by 2, by 2, by 2. That seems to be okay. But what I see right off the bat is the fact that this is not 100%. This would be considered 86%. So we're not showing the full range. We're also starting at 76, which makes a distortion between the bars. The scale on the vertical axis is exaggerating the difference between the sizes of the bars. This graph shows customer satisfaction with different brands. What might someone believe because of the graph? They might believe that the satisfaction with brand B is significantly higher than the other brands. But in fact, it's only 3 points higher than brand D. Let's look at example 1. Check it out. Who might want to use the graph at right to explain how their fertilizer is better? Let's look at company D. The fertilizer from company D appears to be more effective than the other fertilizers. And yet, they're all within the low to mid 80s. Another example, 2A, this graph shows the amount of rainfall by year in a particular metropolitan area. Why is this graph misleading? Well, again, let's look at the vertical scale. Every 2 bars is 10, 2 more is 10, 10, 10, and then 2 bars indicates 5 inches, and the next 2 bars indicate 5 inches. So the scale on the vertical axis it's not equal, which is misleading, and it draws the graph out more. What might people be influenced to believe by the graph? They might believe that the amount of rainfall decreased the most between 97, right here, and 98. We can see a drastic decrease. However, the change between 97 and 98 was only 8 inches, while between 1998, right here, and 99, it was 10. So this section of the graph looks way steeper than this section, but the lower section is 10, while the upper is 8. Let's look at example 2. Check it out. Who might want to use this graph? Well, it's showing by the hose on the gas nozzle that there's a great deal of increase from 1995 to 97. It went up 14 cents a gallon to 2 cents a gallon, and between 26 and 43, and between 1999 and 2001, we can see it's probably even higher. It says taxi drivers could possibly want to use this. They could justify charging higher rates by using this graph, which seems to show that gas prices have increased dramatically. A circle graph is something we're going to compare each category to the set of the whole data. When any category is not represented in the graph, it may appear that another category represents a greater percent of the total than it should. For example, let's look at this graph. This graph is showing the amount that the county has budgeted towards all of its costs for the year, but at first glance, if we add up all the percentages, we see 10 and 20 is 30, plus 25 is 55, plus 5 more is 60. There's only 60% of the budget shown here, but it is represented by an entire circle graph. It doesn't add up to 100, so expenditures are not accurately represented. What we might be influenced to believe is that road maintenance, while it states that it's 25%, on the graph actually looks like it's more than 50% of the budget. Let's look at this check it out problem. Who might want to use this graph at right? So again, student council election, we have 3 kids. We're looking at the votes that they received. Adkins with 10%, Smith with 20, and Napier with 5. So if we add these up, we can see 35% of the votes still being expressed in a circle graph, which should show 100% of all the votes, but it's not. And so Mr. or Mrs. Smith might be the one to choose this graph to show that they possibly won the election. Statistics can be misleading because of the way the data is collected or the way the results are reported. A sufficiently large random sample is a good way to collect unbiased data. In a random sample, all members of the group being surveyed have an equal chance of being selected. For example, a study of 5 households found the following number of pets per household: 2, 1, 1, 9, and 2. Explain why the following statement is misleading. The average household has 3 pets. Well, if we add all these up, 4, 5, 6, 15. 15 divided by 5 is 3. However, sample size of 5 households is too small to achieve accurate results. This sample implies that each household has pets, when many probably do not. Another example, researchers asked 4 people if they have seasonal allergies. 3 responded yes. Explain why the following statement is misleading. 75% of people have seasonal allergies. And we can see from the last example that this sample size is much too small to represent all people. We're going to look at this as another practice problem. Explain why each graph is misleading. Let's look at this one. We see our scale, our vertical scale, from 40 to 4750, jumping up by 250, 250, and 250. However, it is a broken graph, which distorts the difference between the bars. It exaggerates the difference. Someone might believe that Studio Z charges much less than its competitors, when in fact 41 probably about $7 less. Why would this graph be misleading? Membership at the fitness center. Well, we'd look at the vertical scale, we'd look over the months, and we might find something over here with the scale. It says the vertical scale extends well below the data set. The number of members did not vary much throughout the year. Part 3, explain why this graph is misleading. Well, we know for circle graphs, we want to look and add up the sectors. So we have 27 and 12, 39. We have 39% of the voters shown, and we know we should see 100%. We also see Gutierrez, 12%, but representing way more than half of the circle. The circle graph needs to represent 100%, while the sectors show that percent out of the whole. And part 4, a researcher asked 5 people if they like to snow ski. 4 responded yes. Explain why the following statement is misleading. 80% of people like to snow ski? Well, while they might like to, I doubt they can afford it. We've got a way too skinny sample, and 5 people, it is way too small to consider it representative of the entire population.